Hello there. So you have been learning a lot about matter and mass and volume. And today we're going to practice using water displacement to calculate volume. So the steps to doing that, you basically place an unknown amount of water into a graduated cylinder. And this is a picture of a graduated cylinder. Maybe you've noticed them by the window in the corner in the classroom. Those tall, clear plastic things with the numbers along the side. Those are graduated cylinders. So we're going to place a known amount of water in that graduated cylinder, and that is what you start with, and we call the amount that you start with the initial amount. Then, whatever object you want to find the volume of, and usually it's an irregular object, so that means there's not a formula to find the volume of it like there is for a cube or a rectangular prism. So you'd place the irregular object into the graduated cylinder that has the known amount of water, and you measure the new amount along the side of the graduated cylinder. Because just like when you take a bath, the water doesn't stay the same, right? When you get into that bathtub, doesn't the water rise up? Yes, the same thing's going to happen when you put this irregular object in the graduated cylinder. It's going to rise up. Then you look at the side of the graduated cylinder, and you see, okay, what did that water go up to? That's called the final amount. So the initial amount's what you start with, how much water is in there. The final amount happens after you place the object in there. And in order to figure out the volume of that object you put in there, you just find the difference, that means subtract, between the final amount and the initial amount. So you take your final amount minus initial amount, and then you get the volume. But remember, when you're finding volume, we're going to label volume with centimeters cubed, and every 1 milliliter is the same as 1 centimeter cubed. So if you're just measuring how much water is in something, you can leave that as milliliters. But when I ask you for the volume of an object, you want to give me that in centimeters cubed. So the first thing we're going to do with these top 5 is we're just going to practice reading the graduated cylinder, okay? Because that's definitely a skill you need to have if you want to be able to use water displacement to find the volume. You have to be able to read the graduated cylinder. And the first thing you'll want to notice when you're reading a graduated cylinder is what the number scale is, what each one of these lines is worth. And I can see down at the very bottom, here's the number 5. If I count by ones, 1, 2, 3, 4, 5, I end up at 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this is counting by ones. So when I look and see, okay, how much water is in here, and it says to label our answer with milliliters, because we're just measuring water here, I would look and see, okay, 5, 10, and then I know it's counting by 1, so 11, 12, 13. So there are 13 milliliters, and it's a lowercase m with a capital L. That's how milliliters are listed. 13 milliliters of water in there. All right, and looking at this next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is counting by ones again. And I want to know how many milliliters of water are in here. Well, here's 5, 6, 7, 8, 9. And 9 is 1 less than 10. That's where 10 is, so it makes sense. So this would be 9 milliliters. All right, next. I don't know that we had to figure out the number scale, because do you see how this is exactly on the 40? Yeah, so there are 40 milliliters of water in this. Now this next one, it looks to me like, again, it is exactly at 20. So 20 milliliters of water. And now for this last one, I did make a little star to let you know we're counting by twos here. See how it goes from 40 to 50? But there are only 1, 2, 3, 4, 5 hops to get from 40 to 50. That means that each one of these lines is worth 2. Because if this is 40, then I'd go 42, 44, 46, 48, 50. So this would be 48 milliliters. So you have to be careful. Usually it would either count by ones or by twos with the ones that you're going to be dealing with. Okay, so now let's practice this water displacement business. It says, calculate the volume of each object using water displacement. The initial amount is shown in the graduated cylinder on the left. Label your answer with centimeters cubed, because in volume, that's what you use. You use cubic units. Okay, so this is the initial amount right here that we were talking about, the amount of water that we start with. And when you look, it looks like 1, 2, 3, 4, 5. This is counting by ones. So in order to figure out what the volume of each of these are, I have to know what my initial amount is, because that's what I have to subtract. So right here, this is 15, right? And we saw we're counting by ones. So 15, 16, 17. So this would be 17 milliliters of water. That's our initial amount. Okay, so basically what we did was we took a battery. I wouldn't recommend taking a battery, but we took a battery and put the battery inside this graduated cylinder that had 17 milliliters of water. And look at what happened to the water. It's not at 17 anymore. What is it at now? Well, when you look, 5, 10, 15, 20, it looks like 1, 2, 3, 4, 5. This is counting by ones, and all of these are the same. So they're all counting by ones. So if this line here is 20, then we have 21, 22. This is 22 milliliters right here, okay? So in order to figure out what the volume of that battery is, we can take the final amount, so that's the amount that after I place the object in, what it went up to, and subtract the initial amount from it. So I would do 22 minus 17, and that gives us the change in how much this water went up, which is the same as the volume of that battery. So 22 minus 17, I would say to myself, okay, well 17 plus 3 is 20, and then 2 more is 22, so 22 minus 17 is 5. We're not going to say 5 milliliters because we're finding the volume of this battery, not the water. And remember that every 1 milliliter is the same as 1 centimeters cubed. So if I have 5 milliliters, that would be the same as 5 centimeters cubed. So that would be the volume of the battery. All right, for letter B, we had a nail that was put in there. Okay, so it was at 17, and now where's it at? Well, this is 15, 16, 17, 18. So our final amount, the measurement after we put the nail in, is 18. I'm going to take away the initial amount, 17, and 18 minus 17 is 1. So 1 milliliter is the same as 1 cubic centimeter. So the volume of the nail is 1 cubic centimeter. All right, now we have a button. If you want to press pause and try this one on your own, go for it. If not, it's not a big deal. So we put this button in here, and what's the volume, or where's the water at now? Well, you could see that this is counting by 1. It's 1 less than 20, which is 19. Or you could have said 15, 16, 17, 18, 19. So this is at 19. That's my final amount. I'm going to subtract my initial amount, which we started with 17, and 19 minus 17 is 2. And the button's not 2 milliliters because the button is not water. The button would be 2 centimeters cubed because every 1 milliliter is the same as 1 centimeter cubed. All right, now we have a key. So let's see where the key is at now. I see it's right on the 20. So in order to find the volume of that key, we would take that final amount, subtract our initial amount before we put the key in, and 20 minus 17 is 3. And that means 3 centimeters cubed. 3 cubic centimeters is the volume of the key. So what you're going to do is you're going to do 2 practice sheets after this. I have them attached. And if you are not able to print, don't worry. You can just write these answers in your spiral notebook. But you'll just write like side 1 and number them. And then side 2 and number them. And I am planning to put the keys on there so you can check your work after you're done to make sure you're on the right track. And if you are not on the right track, then send me a message so I can give you some support. Thanks for watching.